Let's look at how different vertical temperature variations can result in different types of precipitation at the surface of the Earth. I'll start with a straightforward case, depicted on the left. When temperatures throughout the entire troposphere are less than the melting point of ice, and clouds are sufficiently cold enough for ice crystals to grow, only snow can reach the ground. But for scenarios in which temperatures aren't cold enough to sustain snowflakes all the way to the ground, the pink layer represents air with temperatures greater than the melting point of ice. That's 0 degrees Celsius or 32 degrees Fahrenheit. So over here on the right, when snowflakes fall through a layer of air that is warmer than the melting point of ice, snowflakes start to melt. Assuming that the temperatures in the warm layer are a few degrees above the melting point of ice, snowflakes will melt completely into raindrops, and rain will be the observed precipitation type at the surface if the warm layer extends down to the ground. That seems simple enough, but sometimes in the atmosphere, a warm air sandwich of sorts develops. In other words, there can be a layer of very cold air near the ground, a slab of warm air a few thousand feet aloft, and cold air above the warm slab. When a warm air sandwich develops, that's when sleet and freezing rain enter the picture. When snowflakes melt partially or entirely into raindrops when falling through a warm slab of air, they can refreeze into ice pellets called sleet when the slice of cold air next to the ground is relatively thick. I emphasize that this freezing is contingent on the slice of air next to the ground being thick and cold enough to do the job, because raindrops don't refreeze immediately when entering the bottom slice of cold air. Refreezing takes some time, so having a thick layer of sub-freezing air to fall through assures that the raindrops will refreeze into ice pellets before hitting the surface. Upon hitting the ground, sleet typically bounces. Now, when the layer of cold air near the ground with a temperature less than 0 degrees Celsius isn't thick enough to refreeze the raindrops, freezing rain is the result. When freezing rain is observed, liquid raindrops don't have time to freeze in the layer of cold air near the ground, so they become supercooled, which means that they're liquid that exists at temperatures less than the melting point. These supercooled raindrops freeze on contact with cold objects such as untreated roads and sidewalks, power lines, and trees. Freezing rain creates a slippery glaze, and when heavy, it can produce devastating ice storms as the weight of ice accumulating on tree branches and power lines brings them down.